Alright, still on the subject of electric fields, this topic is electric potential in a uniform electric field. A uniform electric field. The uniform electric field is the field that is, we describe a uniform electric field as the field inside of two parallel plates. We've been talking about these two parallel plates this whole lecture. In our thought experiment, this is what I wanted you to picture in your mind. Was that we were walking around on a surface that's positively charged, we're positively charged ourselves, there's a negatively charged ceiling. And no matter where we went, high or low, near and far, we would always experience the same force. And if that force upward was equal to the force of gravity, then we could float around. But that's not really practical, but it's a nice thought experiment. What I've drawn here is some wires attached to these plates. These are literally plates like aluminum or tin pie plates. You can buy 10 for $1 at Walmart. This is literally what I'm talking about. Pie plates. Metal pie plates. And if you arrange them parallel at a set distance apart, and you connected wires to them, and you connected a battery to it, you can have a demonstration circuit just like this. You could play around with the charges and things. And if I could do a little take-home lab, and I say, go out to your garage, get some pie plates, get a 9-volt battery, set this up, get a little charge tester, measure some variables, and if you fooled around with it enough, you would find this relationship between the distance between the plates, the voltage of the battery, and the strength of the electric field. The relationship is the strength of the electric field is equal to the voltage of the battery divided by the distance between them. It's simple, it's eloquent. But I've used a new word here, voltage. So I need to stop and talk about that. It's not a word that's foreign to you. You have AA, AAA batteries that are 1.5 volts. You also have the C and the D variety of those batteries. You have a 12-volt battery in your automotive, in your cars, automotive 12-volt batteries. You have all kinds of different batteries that go into your devices and your cell phones. And each of them, you have to get the right voltage, right? And the manufacturers of those batteries make sure that you don't put the wrong voltage in the wrong device because so they make them a certain shape and size. So that only the right battery is going to fit in there. Right? So you're familiar with the term voltage. It has to do with batteries. But what does that voltage really mean? And why is this distance relationship in here? And what's that got to do with the electric field force? Well, the book goes into a lot of detail about that, and I don't want to teach that to you because I have something very specific I want to teach you, and I don't want to get bogged down in the idea of work. Because there is work being done, and that has everything to do with what voltage is. The work being done is if I'm a charged particle inside the space between these two plates, and I'm getting moved, if the beam is being deflected, I'm doing work because the particle has mass. Remember that charged particles are either ions or electrons, and ions and electrons have mass. So if I move a mass a distance with a force, I'm doing work. You guys remember last semester? I pushed this chair around a lot, right? I'm doing a force. I have a force on this chair, and I'm moving it a distance, and I'm doing work. Right? Work is equal to force times distance. Right? That's what work is. And if I have a job pushing chairs around, I'm actually doing work, right? I get paid for doing that work, right? This force times this distance, I'm doing work, I get paid for that. Pretty good job. It's a good one if you can get it. Right? So I'm doing work, I get paid for it. Voltage has everything to do with the amount of work being done. And the amount of work being done, of course, has to do with the space that you're pushing those electrons. That's why D is a factor, right? Same concept. So we call V electric potential. Make sure you got that in your notes. V voltage is electric potential. There must be some guy named V, right? Some guy Volt. Must be some guy named Volt. He got that named after him. Isn't that like the every physicist's goal is to have some unit of measure named after him? Newton, watt, volt, ampere. Volt is electric potential. Your battery has a potential to do work, right? Your car battery has a potential to start your car. Your phone battery has a potential to make calls, right? So that's where the potential is. The electric potential is in the battery. And based on the voltage of that battery, that tells you how much work it can do. Right? So that's where this term V comes from. And this is a relationship between the electric field strength, the voltage, and the distance. Okay. So we have another relationship. We have another formula that we can do a whole other set of problems on. So let's do a couple of problems. Turn this off. Talk to myself.